Let's find what is dA d theta. So with this that I have from part 1, dA d theta, this is going to be equal to 600 cosine theta plus 200 multiplied by cosine 2 theta multiplied by 2. So dA d theta is 600 cosine theta plus 400 of cosine 2 theta. And what I'm going to do next is to let dA d theta be equal to 0. So letting dA d theta be equal to 0 will help me to find the value of theta when A is stationary. So 600 cosine theta plus 400 cosine 2 theta is equal to 0. 600 cosine theta plus 400 of this. This I'm going to make use of trivial identity to change this to 2 cosine square theta minus 1 is equal to 0. And if I were to divide throughout by 200, this is going to give me a 3 cosine theta. This will be 2 of 2 cosine square theta minus 1 is equal to 0. Expanding this and this, it will give me a 4 cosine square theta plus 3 cosine theta minus 2 is equal to 0. In order for me to solve for cosine theta first, I'm going to make use of the quadratic formula. So cosine theta is minus b plus or minus square root of b squared minus 4ac divided by 2a. And cosine theta is going to be minus 3 plus or minus square root of 41 over 8. And I know theta from observation is going to be a value that is between 0 and pi over 2. So I'm going to just let cosine theta be minus 3 plus square root of 41 over 8, which is going to be a positive value that will help me to find theta when it is acute. So this is because I'm saying that theta from my observation, it is going to be between 0 to pi over 2, which means that theta is going to be equal to 1.13. From what we have done here, we have managed to find the value of theta when A is stationary. I still need to do one more step so that I can prove that this stationary value of A that I found for the value of theta that I've obtained here is a maximum value. So to do that, I can either use the second derivative test or the first derivative test. Looking at what I have here, I will probably go for the first derivative test. So if I were to go for the first derivative test, I'm going to look at theta. And when theta is equal to this 1.1314, I'm going for 5 significant figure, 1.1314, a little bit less than that, 1.1314, a little bit more than that. And I'm going to look at the sign of dA d theta. This is definitely going to be 0 because that is what we set out to do. This, if I were to plug into my calculator, is going to give me a positive value, and this is going to give me a negative value. So the shape of A is going to be here, it will be horizontal, positive gradient, negative gradient. What this shows me is that A is a maximum value when theta is equal to 1.13. That is why the trough will have a maximum amount of water when theta is equal to 1.13.